A basketball player has a 60% chance of making a free throw. What is the probability that the fifth successful free throw occurs on the eighth attempt? Now, if you've watched our previous videos on binomial distribution and geometric distribution, which I highly recommend you check out, you'll notice that this problem feels familiar. It's almost like a mix of both. In the binomial distribution, we focus on the number of successes within a fixed number of trials. While in geometric distribution, we're interested in the trial on which the first success happens. But this time, we're not just looking for the first success or counting the number of successes. We're focusing on when the fifth success occurs on a specific attempt. This is where the negative binomial distribution comes into play. So, why is this different? Well, the negative binomial distribution deals with scenarios where we want to find the probability of a certain number of successes, but with a twist. We're asking on which specific trial that last success will happen. In this case, the fifth success on the eighth attempt. This distribution tells us the probability of getting a specific number of successes over a sequence of independent trials, with the last success occurring on a specific trial. Whenever you come across problems that involve a sequence of trials, with a set number of successes and the last one happening on a specific trial, that's a strong indicator you're dealing with negative binomial distribution. The key structure to remember is, you're counting the trials until you hit the K success. Now here's how the formula goes. The probability of getting the success on the nth trial is equal to the combination of n-1, choose k-1, multiplied by the probability of success, p, raised to the power of k, multiplied by the probability of failure, 1 minus p, raised to the power of n minus k. Where n is the trial on which the last success occurs and k is the total number of successes we're aiming for. Here, the n-1, choose k-1, refers to the number of ways to arrange the successes and failures before the final success. Also, p is the probability of success in a single trial. Therefore, 1 minus p is the probability of failure. Alright, if you remember the binomial distribution formula from one of the previous videos, you'll notice that the negative binomial distribution formula is quite similar. The main difference is that the negative binomial focuses on counting the number of trials up to the kth success, including both successes and failures, whereas the binomial distribution counts the number of successes in a fixed number of trials. This small change in focus can actually make it easier to remember the formula if you're already familiar with the binomial distribution. Now, let's go ahead and solve the problem using the formula for negative binomial distribution. The probability of success, p, is 0.6, since the player has a 60% chance of making a free throw. We want the fifth success, so k is equal to 5. The last success happens on the eighth attempt, so n is 8. The formula becomes 8 minus 1 choose 5 minus 1, multiplied by 0.6 raised to the power of 5, multiplied by 1 minus 0.6, raised to the power of 8 minus 5. Calculating all of these together gives us 0.174, or the probability that the basketball player makes his fifth successful free throw on the eighth attempt is about 17.4%. Alright, let's kick it up a notch with another problem. A salesperson has a 30% chance of making a sale on each call. What is the probability that the fourth sale occurs on the ninth call? Now, just like the first problem, this one asks for the probability of the salesperson achieving a specific number of successes, in this case, 4 sales, on a specific attempt, the ninth call. Since we're looking for the probability of the fourth success occurring on a particular trial, this is another example of a negative binomial distribution problem. What makes this problem negative binomial is the same reason as before. We're not just counting the number of sales made in a fixed number of calls. Instead, we're trying to find out how many calls it takes to make the fourth sale, and we want the last successful call to happen exactly on the ninth attempt. Now, let's proceed with the solution. In this case, p, the probability of success is 0.3. K, the number of sales or successes we are aiming for, is 4. And n is equal to 9, since we want the fourth sale to occur on the ninth call. Using our negative binomial formula, we have combination of 9 minus 1 choose 4 minus 1, multiplied by 0.3 raised to the power of 4, multiplied by 1 minus 0.3 raised to the power of 9 minus 4. Now this is equal to 0.0762 or 7.62%. This is the probability that the fourth sale occurs on the ninth call. Alright, I hope these examples gave you a clearer and more intuitive understanding of negative binomial distribution. As you've seen, it's a powerful tool for calculating the likelihood of achieving a specific number of successes over a series of trials when you're focused on when that last success occurs. If you enjoyed this deep dive into probability, be sure to check out the other videos in our probability series. Thanks for watching, and good luck on your exam.